subscribe to our YouTube channel, Joy Learning TV.
Today we are with the senior high school mathematics, that's called mathematics for Shs-2. My name is Evans Ode. Today we are starting a new part. So today may be part 1, and it's likely we are going to do part 2 and part 3. And the topic for the day is quadratic functions and equations. Book your pens, then we move together. As usual, our starter, a mental exercise to prepare us for today's lesson. And here, application with a number that ends with 5. So, other way around, we can say, how fast can you square a number? You should be able to square any 2-digit number or even 3-digit number that ends with 5. So, let's see a few examples. If I give you a number like 30 in less than 5 seconds. Now, observe something. Any number that ends with 5, if you square that number, it will always end with 25. That's observation that 5. So if I have 35 times itself, all you need to do is to pick the first digit or digit before the 5. Now here we have 3. Next number that comes after 3, and that is 4. So multiply the 3 by that number 4. 3 times 4 is 12. So 12, and the answer becomes 1,225. So 35 times itself will give you 1,225. Can you do that? Again, just pick the 4 times the next number after 4 is 5. So 4, 5, 20. And so 20 becomes the first 2 digits, and 25. You can do this as a form of mental exercise. Give yourself a number that ends with 5 and square it. And then try your brain cells. Let me give you one try. In less than 5 seconds, can you multiply 75 times 1, 2, 3, 4, 5 seconds? So you are at 25. So we say 5,625. Let's try another one. What would be 95 squared? Good. So 25. And so we say 9,025. So you can do this as a form of exercise for yourself. So let's get back to quadratic functions and equations. By the end of this lesson, identify a quadratic function, an equation, and the nature of curves they come with. Then solve quadratic equations using factorization. So these are the few objectives you are going to achieve by the close of this episode. Now let's start with function or quadratic equation. Let's start with the word quadratic. The name quadratic comes from the word quad because the variable that is being used gets squared. And so anytime you have an expression that has got the highest degree with quadratics, so that is the word quadratics. The standard form of every quadratic function is bs plus c. That is the standard form of every quadratic function. And the function can be x, or we can say evans of x is equal to, and if evans of x is quadratic, then I would say as squared plus bs plus bt plus c. I have the highest degree to be 2, then it forms quadratic. C to be constants to be determined. And this constant determine the shape and the position of 0. I will explain that to you. The a that we have here should never be equal to 0. Now the question is, if a goes to 0, what happens? bs plus c, which forms a linear function. And so for us to maintain quadratic, then the coefficient of the s squared must always be Then we have this information here. B and C can be any value, positive, negative, or 0. It won't change the quadratic. It's equal to 0. The function becomes a linear. Right. So if you look at the example that I have here, f of s is a s squared plus bs. Here, and again, when the b also goes to 0 and we have as squared plus c, it is still quadratic function. We can also have a situation whereby b goes to 0, c goes to 0, and when the a becomes 0, then the whole thing ceases to be a quadratic function. So if you look at this diagram that I have, a changes, the curve changes in terms of its wideness or narrowness. So you can see that as it becomes 0, the curve now becomes a linear, and the equation becomes y is equals to bs plus c. Now look how it doesn't change. When b is 1, 2, or 3, I still get my curve, just that the position of the turning point will change. Then c also helps. You can see when c is 0, we'll still get curve. It doesn't change the nature of the curve to be a linear or cubic. So that is what I want you to take note of. Take functions. Like I have 3s squared plus 5s plus 2 can be an example of quadratic function. G of x is 2s squared plus 9 is a quadratic function. Y is equal to fx squared minus x is a quadratic function. So in each case, we are maintaining the square in each of the functions of h of m. In that case, I'm going to have maybe 3m squared minus 4m plus 5. This, I've not mentioned equation yet. All this we're mentioning functions because there's a function that is defining the quadratic. So that is quadratic function. Now look at this. When the function goes to 0, that means y is equal to 0. Then what happens? The whole function now becomes an equation. The moment we equate the function to 0, then a quadratic equation. That becomes quadratic equation. And here you can see that the curve here is an axis. And so when that happens, that means that any value we pick on the x-axis, y is equal to 0. So the whole of this function becomes 0 here. And then we get quadratic equation. But as much as we have our y in position s squared minus 5s plus 3 equals 0, I can also have it like this. S squared is equal to 3x minus 1. This one, you don't see the 0 here, but if I'm to rearrange them in the form of as squared plus bs, or make the whole thing equal to 0. So I can write this as s squared minus 3x plus 1 is equal to 0. And so I still get quadratic equation. It forms quadratic equation. What if I have a squared is equal to 36? Can we call this quadratic equation? Yes, because we have our a squared. In this equation, the b term or the x term is 0. And then the constant c is negative 36. And then look at this equation 2. Can we call this quadratic? Yes, we can. Because if I try to expand this, I'll write 2w squared, bring the 5, and then equate the whole thing to 0. And that still remains quadratic equation. Every quadratic equation, like we saw from the first video. Now, observe something. If the coefficient of the s squared, that is the a part, is positive number, then the curve will be a minimum curve, concave upwards, or minimum curve. And when the a value becomes negative, then we get a concave downwards, or maximum is the minimum curve. We'll be looking at this in part 3. Into details, we'll draw a graph of this sort when we come to part 3 of this series. Right. It's sometimes called parabola. So sometimes called parabola. So those of you who are doing elective maths, we have coordinate geometry 3, that is parabola. And so I'm sure your colleague teacher who is handling elective maths will take you through that. So observe critically and you come across a topic called parabola in this series. So in quadratic functions, we see a lot that can model a quadratic function. We can see this type of structure models a quadratic function or parabola. Look at this arc. It also models. Engineers will not leave mathematics and do anything. They must always go with maths to design things of this sort. So you see this bridge also can model quadratic curves. For every quadratic function or equations, we have two solutions. Or let me put it this way. There are two solutions to quadratic equations. And they are sometimes called the zeros of the equation. If I give you a function and I say find the zeros of the function, then I'm telling you to equate the function to zeros, two possible solutions. Now, 2 because of the s squared. So if I give you y is equals to as squared plus bx plus c, and you equate this function to 0 and solve it, if the power goes to 3, which we call cubic, then we'll get 3 possible solutions. If the power is 1, which becomes linear, then you have only one solution. So as and when the power increases, we get the number of solutions in response to that. So if the power goes to power 4, then when you solve it, you should get 4 different answers for the value of x. So that is what we refer to as the solution to the quadratic equation. So for solution to quadratic equation, how do we see this if we are able to graph the function? If you graph the function, wherever the function cuts the x-axis, the two values that the function meets the x-axis at becomes the solution to the quadratic function. And so if you look at this function here, y is equal to s squared plus 2x minus 3. If you graph this, this is the curve you're going to meet it here at positive 1. And so the solution to this curve or this function is s is equal to -3 or x is equal to positive 1. What it means also is that if you equate this to 0 and solve it quadratically, that is using the methods you're going to use right away to solve them, you end up getting 2 possible answers, which will be s equals -3 and s is equals to 1. Right. This curve of yours. So here we have -2 and we have positive 1. So for this very function, if we equate it to 0 as an equation and you solve it, you get s is equals to -2 or x is equals to positive 1. Sometimes you can get quadratic function where the curve will not meet the x-axis at all. For example, I could draw a curve which will go this way. It will never meet the x-axis. It's still quadratic function. But this type of function, we say it has no solution. It has no solution. When you try solving it, you end up getting undefined or complex roots. If you do complex mathematics or complex numbers, you will understand where we say complex roots. But for now, we will say no solution. Then we have a situation whereby the curve will sit on one point on the x-axis, exactly at one point. Here we see what we call repeated roots. So when you solve a question of this sort, you get s is equal to 3 or x is equal to 3. You get the same 2 solutions. And that's what we call repeated solutions. We'll look at that in our next meeting. And with this very question, where we have y is equal to -x squared plus 5s minus 2, you can see that the curve will meet the x-axis at this point. Probably that will be 0.5, and then here maybe 4.6. And so this 0.5 and 4.6 will be the solution to this function when you equate it to 0. Now, let's look at how to solve quadratic equations. Now, we've seen functions, we draw functions, we sketch them, or we can draw them using the graphs. We'll come to a section whereby we'll be looking at how to graph quadratic functions. But now we want to learn how to solve quadratic equations. And there are 4 different ways we can do this. At our level, we can use 4 ways in which quadratic equations can be solved. And we're going to look at all of them. We'll look at the first 2 in this section, or this part. In our next meeting, we'll look at the remaining 2. So, we are going to look at factorization method. And we'll look at completing the squares, general formula, and then we'll look at graphical method. So these are the 4 ways at our level we can use to solve quadratic equations. Factorization method, completing the squares, general formula, and graphical method. We are trying our best to finish the first 2 in this section. So let's start with factorization method. How do we solve quadratic equation using factorization method? And I'm sure the word factorization is not a strange word to you. In algebraic expression, we learned how to factorize expression. In algebraic expression, we learned how to factorize expression. And at a point, we even learned how to do quadratic trinomial. Quadratic trinomial, that is having an expression of, let's say, 3x squared plus 5x minus 6. This is quadratic trinomial, and we learned how to factorize this. And this same approach is what we are going to use in doing factorization. We equate this one to 0. So let's start with example. Find the roots of the equation, this, or let's find the solution set of this equation. 6x squared plus 7x plus 2 is equal to 0. How do we solve this equation? So I'll take you through the steps. Then I'll also give you a shortcut in doing this without going through all the process. So let's start. Right? If you just join us, this is 1. Quadratic Functions and Equation Part 1. And what we've gotten to is we are learning how to solve quadratic equation using factorization method. So we'll start. Now we have our 6x squared plus 7x plus 2 is equal to 0. Right. The first thing to do is to look at the a part of this expression. Remember we said quadratic expression normally goes with ax squared plus bx plus c. And so the a part represents here 6. B part in this equation is 7. And the c part is 2. So the first thing to do is to multiply the a part to the c. And a we have 6. And b and c we have 2. So 6 times 2 will give us 12. Let's put a 12 somewhere here. Now, the next thing to do is to look at or pick 2 numbers that when you multiply, you get a 12. You want the factors of 12. Or 2 numbers that when you multiply, you get 12. We know that we can multiply 1 and 12 to get 12. We can do 2 and 6 to get 12. And we can do 3 and 4 to get 12. Now, with this pair of factors, which of them that when you add, you get the middle part of this work, or the b term? Which of them when you add, you get the b value, that is the 7? Which of them? Look at 1 and 12, it won't help you, so that is out. 2 and 6 will not help you. This and this will be able to help you get that. So it means we need 3 and 4, that when we multiply, we get a 12, but when we add, we get the 7 here. If you do this method, or you are doing this method, and you realize that none of the pairs can give you the 7, then what it means is that this very question cannot be solved using factorization. In that case, you need another method, and that will be the method that we will learn. That is either completing the squares or using the general formula, which some people call it, or we call it, almighty formula. All right, we'll look at that. So we have our 3 and 4. So what I'm going to do next is to replace 3 and 4 to where the 7 is, and we attach s to them. So I can write this as x, 6s squared is here already. Then instead of 3x, then 4x. So it means that in place of the 7x, I can now put this and that, and then bring the 2 that I have already here, and then a 0. And we get a 7x. Then maintain all other numbers. Now, initially we had 3 terms at the left-hand side. This one we are going to have 4 terms. And 4 terms means, so I'll look at the first 2 and do factorization, and the next 2 and do factorization, and equate all of them to 0. So for the first 2 here, what will be the common? That will be 3s, right? So I can say 3x into brackets. Now what do we put here so that when we multiply by the 3s, we give us 3x times 2s, I get 6x squared. Then plus, here I've taken 3s out, so what I can write here is 1. So that when I say 3x times 1, now with the 4x and that of the 2x, we can also factor a common factor out, and that will be 2. Taking 2 out, we have 2x plus 1. Everything is equal to 0. It gave us quadrinomial, that is 4 terms. Now we've been able to factor back to 2 terms. The whole of this represents 1 term, and this represents 2 terms. And you can see that the common factor is 2x plus 1. So bring it out. What is left here is 3x plus what is left here is 2. See, we are having 2 numbers, 2x plus 1 times 3x plus 2. We have to multiply the weird in that s can be any number. Assuming I put, let's say, s to even 0, then I can say 0 times, I'm going to get 0 plus 2 is 2. 2 times 1 should give us 0. And that is not possible, right? So what we are saying is, if 2 numbers, else this will not be possible. You can't multiply 2 numbers and get 0 when one of them is not 0. So 2x plus 1 could be, if it is 2x plus 1 that is equal to 0, what is the value of x? And if it is 3x plus 2 that is equal to 0, what is x? So here for the first one, we divide both sides by 2. We have x is equals to negative half. Or if it is this one 2, we have 3x is equal to negative 2. Divide both sides by 3, we have our x is equal to negative 2 over 3. Of this quadratic function or equation are negative half and negative 2/3. These are the roots of this equation, and this is how we find the solution to the quadratic equation. Same, I'm going to do a different method to give you the same answer, which I call the trick. How do we use trick in doing this without going through all the process? So I can skip all this part and get the same 6x squared plus 7x plus 2 is equal to 0. So all I'll do is that I'll pick the 6 and then the 2, multiply them and get 12. Find the factors of 12. That is very important. So we saw that was 4 and 3. Now this 4 and 3, just write them down. And then switch their signs. Now they are all positive. So you switch the signs and you get negative, negative. Then divide squared. So here by 6, here by 6. Reduce them to the lowest form. You have 2 on 3 and then negative 1 on 2. And these are the answers we had. Go through all the process and you don't have calculator to use just to get your answer so fast, you can use this trick to get your answer in few seconds. Right. Let's take another example. Equal to 3 into bracket 2x plus 9. Probably you might seem this not to be a quadratic equation, but it is, because we saw similar example earlier. Once I have this, 6x plus 3, 9, 27, right? I can rearrange this as x. Now it's good to arrange them to be in a format of quadratic equations to 0. Again, we are going to go through the same process. I'll first look at the coefficient of the x squared, and that is 1. 1 times the right. 1 times negative 27 is 27, negative 27. Then we pick two factors of 27 that when we multiply, we'll get a negative 27, but when we add, we'll get a negative 6 here. When you multiply, you get 27. Then we can take 3 and 9. And 3 and 9 also will multiply to give you 27. But then because it's negative, it means one of these pair, 1 times 27 is negative 27. Or if I keep negative to the 27 and keep positive to the 1, I will still get negative 27. Then with the second pair, A times negative 9 will still give me negative 27. So I have to choose one. But then I will choose one depending on which of them that when I add, I'll get my negative 6. 27 and get negative 6 out. Then the second one is negative 3 and 9. If you add negative 3 and 9, you get positive 6. That is not what we want. So we have 3. So we are going to replace 3 and negative 9 in place of negative 6 and attach our x. So we have our x squared here. Then so plus 3x. Then minus 9x. Then I can bring my negative 27 equals 0. You see, so what I've done here is just replacing 6x. Now I can split them and factorize. So I'll do the first two. Common factor for x squared plus 3s. I have common factor is x out, x plus 3. Negative 9x minus 27. Which should come out? Which one should come out? We can say 9 out. We have x. Put positive 3 here so that negative 9 times 3 will get back the negative 27. But if you keep the negative here, it means here already. So we have this. All right. Now, we have two terms now. So let's factor. 3x, 3 plus, sorry, s plus 3 and s plus have x minus 9 equals 0. Again, this times this equals 0 means one of them ought to be 0. So either is x plus 3 that is equal to 0, in that minus 9 that is equal to 0, and our s becomes positive 9. And so this becomes our answer. So, but then the question is, and here we have two answers, but they said s should be less than 0. So we pick the two answers among them, which of them is less than 0? And that is negative 3. So we can say, therefore, s is a condition. You have to obey the condition. Can we do trick on this? Yes, we can do it. Let me do that quickly. So x equals 0. How do we do the trick? We still multiply the one here by negative 27, and that will give us negative 27. Find the factors of negative, negative 9. These are the two numbers that when we multiply, you get negative 27, and when we add, we get negative 6. So we bring those two numbers, and for the 9, it is negative, so I'll keep the positive. And divide each of them by the coefficient here, which is 1. And so therefore, my x will be negative 3. Our next question is this. The length of a rectangle is 5 meters longer than its width. The area of the rectangle is 84 meters squared. Find the dimension of this rectangle. Beautiful. This is a question that will generate quadratic. So you can see that mass is like a chain. We always say it hooks each other. I can learn quadratic and learn plane geometry quadratic. So let me forget about it and then go and learn a new topic. You end up meeting the same thing over there. This is plane geometry, and yes, we are going to use quadratic in solving it. So let's see what the width. All right. And then the area has been given as 84. We want to find the dimension of this rectangle. So if here's length and here's W, we want to find a dimension. So now let's have this as our rectangle, purple being the width. Now the question says the length is 5 meters more. So I want to represent the width by X. Okay. And then the length is 5. It's set for the video. And on equation 2, you see what problem over there and you go through that. So, and then the area was 84. If that is true, then our area is equals to the length times the width. And that becomes an equation. Let's try solving this. Let's try to the length is s plus 5 times the width, x. So we have 84 is equals to s squared plus 5x. That is multiplying this to move this here to join so that we can equate everything to 0. That becomes that. So when you take your time and you go through this, you end up getting your length to be 12 and then your width to be 7. That is solving this quadratic for the factors of 84. That is negative 84. And then try solving this and see whether you get the same answer as this. Another question here that I'll give you a clue to it and then you solve it. The perimeter of a square. The perimeter of a square. So I have a square here. All right. The perimeter means, let me assume maybe, let me call this one n. Here also will be n because we know square is a plane figure or is a quadrilateral that has all sides equal. And so here is our n. And the perimeter means adding all the sides. So if I add n plus n, I have 4n. And then the area of this same square, when I'm to find the area, is length times breadth. And so the area also will be, so let me write perimeter here. And then our area will be equal to n squared. And the question says that the perimeter of the square is 4 more than its area. How it's going to look like. Beautiful. So we rearrange this as n squared. Then remove this. So that will be negative. So I'm moving this one to the other side, and that will be negative 4n. Then plus the 4 here already, and equate everything to 0. Then we solve this in a quadratic form. And when we do that, you end up getting our answer to be, I think you get an answer to be 2. I didn't write the answers. But when you solve this quadratically, you get n is equal to 2 centimeters or meters. The question gave you 4 meters long, so it will be meters. Beautiful. Now let's look at the second part of this series. I mean this section. That is solving quadratic equation using completing the squares. So I'll take you through some steps on how to complete squares, and then we'll take example under it. Maybe that will end part 1 of quadratic function and equations. So here we have a question here. We want to solve quadratic equation 2x squared plus 5x minus 3 is equal to 0 using completing the squares. I'll be giving you the process, the step-by-step process. So let's start. The first step to do this, the other side of the equation. So it will look like this. And this is negative, so when it goes to the other side, it becomes positive, right? Good. That's the first thing to do. then 2. And so the coefficient of the s squared, according to the question given us, is 2. So I'll divide everything by 2. And that will give me x squared plus 5 over 2x is equals to 3 over 2. Remember, before that, the equation is equals to 3. And so I divide everything here by 2 just to make sure I get the coefficient of x squared to be 1. So again, the first step is move the constant term, that is c term, to the other side of the equation. The second is to make sure the s squared of your quadratic divide through by that coefficient so you can eliminate whatever coefficient it is to be 1. Then the next thing is to pick this part of the equation. Okay, that is the b part. Take it out. So let's say I take it out as 5. Sorry, I divide by 2 and square the result. Let me do it again here for you to see. So the next step is that take half of the coefficient of the x term, square it and add it to both sides of the equation. So multiply by 2. Then the whole thing is squared. And when you simplify this, you end up getting something like 5 on 4, all squared. Remember, this time this will be 5, and then this time that will give us 4. So all squared of the equation. So look at the original equation, and I've added 5 over 4 squared to both sides of the equation. So I get something like this. Then our next point is to complete the square. And by completing the square, so here we had s squared plus 5 on, let me move back a bit. Yeah, 5 on 2 x, and the other side was 3 on 2. We added the same 5 on that squared. Good. So what happens is we get this. Now I complete the square by picking only this, and of course you can do that by squaring 5, which is 25 over 16. And when you find the LCM of that, you end up getting this. And this is arithmetic, and I believe you can do that. And you end up writing this. And then you are now going to simplify and make s the subject and add plus or minus on the right hand side. So we are going to get something like this. Because I want to get rid of this square, I must root both sides. So I'll root this and I'll root that. Remember, when you root, you get plus or that, and we get this. Then the next stage from here is to move the whole of this to the other side. That'll be minus 5 on. Here's what we get. So that simplify and make as a subject. Our answer is going to be 2. Remember, we have two answers. One is going to be plus of 7 over 4 minus 5 over 4, or the other will be minus 7 over 10, s is equals to half, and the other side you end up writing s is equals to negative 3. So this is the solution to this question. So here we have s squared plus 2x minus 15 is equal to 0. Now, once we say s squared plus 2x, we move the constant term to the other side to make sure it is 1. In this question, it is 1, so we won't divide anything again. The next thing is to take this particular value, okay, keep it aside, that is 2. Half it. When that is done, you get 1 squared. Add it to both sides of the equation, so we have s squared plus 2x plus 1 squared is equals to 15 plus 1 squared. Then we complete the squares. So we pick this as x as 15 plus 1, making 16. Now the question that you may be wondering, what happens to these two? What is happening is that if I have this x plus 1 all squared and I try to expand it, I will end up writing s squared plus 2x, this and this, which of course when I expand it, I'll get it back to the original. So there's no problem with that, right? So what will I do next? I want to square both sides so I can eliminate the squares. So I'll just root both sides rather. And this will have x plus 1 is equals to plus or minus root of to plus or minus 4 minus 1. Two possible answers are x is equals to plus 4 minus 1, which will give us x equals 3, or x is equals to minus 4 minus 1, which will give us x is equals to negative 5. Beautiful. And so these are the two answers that we will have. Now, I will leave you with the following questions to solve on your own, but I will give you the final answer so that, or using the completing the square method, solve this equation. This doesn't look like quadratic because there's no square in it. But if you try doing cross multiplication by rearranging it, you end up writing quadratic equation. You can solve it using completing the squares. Right. Then, another question is here for you. X is equals to 1. Right. So try to do this on your own and make sure you get the answer as I have here. I'm sure you've enjoyed this lesson up to this very point. This is quadratic function for Shs-2, and we've been able to go through part 1 of it. Now you've known, at least you know quadratic function, you know quadratic equations. You know that every quadratic equation has two possible solutions. We've been able to solve quadratic equations using two different methods. The first method we use happened to be the factorization method, and the second method was what we just finished as completing the square method. I'm sure you've enjoyed this lesson on quadratic function and equation. So thank you so much for choosing Joy Learning channel. My name is Evans Ode. I've been your facilitator. Enjoy the rest of
Subscribe to our YouTube channel, Joy Learning TV.